Acha, today we'll be starting rotation. In the rotation, the basic part we already know. It's what basic part I'm talking about. That thing in the circular motion I have told you, na, that uh, those things, how we compare translation with rotation, those formulas. You remember that? Those things. Let me show you. I'm talking about motion in a plane, circular motion. Ah, This part I'm talking about. When we discuss this circular motion, we have actually covered the initial portion, means the initial portion of the rotation. The how the translation is compared with the rotation, that part. Okay, that part I'm talking. Just how v is equal to u plus at is being used with omega f is equal to omega e plus half alpha t. Those things I expect you know everything. Okay, all velocities, all accelerations that we already know. So now we'll be directly starting with the moment, the next part of the rotation. The next part of the rotation will start from moment of inertia. Now, do you have any idea about moment of inertia? What is moment of inertia? Anyone? Don't worry. See, moment of inertia is actually similar to mass, similar to mass in rotation. How we use mass in translation motion or normal motion, like that we use inertia in rotation. Moment of inertia, actually the mass is also a part of inertia. Inertia is a body to remain, to move as it is. That's the inertia. When we take mass in translation, we take moment of inertia as rotation. Now you need to know how we calculate the moment of inertia. For a body, how the moment of inertia is defined. A body, it's very important actually, moment of inertia calculation. Whenever, the important thing about moment of inertia is it is calculated about an axis always. Means the moment, moment of inertia is associated with rotation. So if a body is rotating, it should be rotating about some axis. That's very important. If it is not rotating about some axis, there is no point of moment of inertia. So because this moment of inertia, this term actually it came when we are talking about the rotation. That's why, means there should be an axis about which it is rotating. So when a axis is there, y dash like this, and there is a body, suppose this is a body whose mass is m, And this body, suppose it is situated at a distance of r unit from the axis. The moment of inertia is given as I about y dash for this body is given by m into r square. This is the important part. Now, like mass, moment of inertia is a scalar quantity. It is represented by I and it is a scalar quantity. So you need not have to worry about adding it vectorially. Means you have to take the resultant and all. Don't worry about that. Means when you have multiple bodies, suppose in next case what I have done, I have taken the similar axis and I have given multiple masses. How? The masses are like this. This is one mass. This is another mass. Let's keep another mass also. Another mass. And let's have have one more mass. The left side. And let's say the distances are given to be, this is the mass is m1, the radius is r1. For this, the mass is m2 and radius is r2. Now for the third one, the mass is m3 and the radius is r3, suppose. Now in this case, the moment of inertia I net will be equal to m1 r1 square plus m2 r2 square plus m3 r3 square. What we have done, we have calculated the moment of inertia of each body about the axis, and then Haripriya was not there in the class. Haripriya, since when you were not in the class?
Sir, I don't know, sir, but I got cut off. I didn't have internet connection.
Acha, no, till where? No, my concern is till where you have understood.
I wasn't there for all of this.
Oh, oh, oh. See, what I told, na, till now, what I told, the basic part of rotation means means the comparing the translation with rotation that we have done in circular motion. Beside that knowledge, actually, when we start rotation, we actually revise that. But since we already know that part, I'm not doing it again. Did in the circular motion. So we are starting from moment of inertia. What I've told here, moment of inertia is actually similar to mass in a translation. It is calculated about an axis. How it is given? Moment of inertia about an axis y dash for a mass m which is present at a distance r from the axis is given by m into r square. Now since it is a scalar quantity, if you have more than one body like m1, m2 and m3 situated at a distance of r1, r2 and r3 from this axis, you can directly because they are scalar quantities, you can just add their moment of inertia, okay, because they are scalar. So in general, up till now I have taught this only. So in general, you can make a formula I net I is equal to sigma mi ri square when I is equal to 1 to n. Okay, now you understood? Haripriya, okay?
Yes, sir.
Okay. Uh, for everyone else also it's okay, na? Simple. Actually, this part is simple up to here. The complicated part will come afterwards. This is a basic way of calculating moment of inertia. Now let me give you Acha. After this, let me give you two more axes, two more theorems. There are two theorems for moment of inertia. One is parallel axis theorem. The other is perpendicular axis theorem. Now, see, you must be wondering, sir, we know how to calculate moment of inertia. Now, why will be using these theorems? What's the use of them? Because without any reason in physics, we do not study anything. In physics or mathematics, there should be a reason. What that reason is, moment of inertia calculation is not that easy. Means every time they won't give you easy questions. They may be changing the axis. Means the axis won't be like this. They may be changing the axis. For that, if they are changing the axis, how do you calculate the moment of inertia? You will be using these two theorems. These two theorems are more than sufficient to calculate every type of moment of inertia, except for uniform bodies. I'll tell you afterwards. Now see the parallel axis theorem, how it is used. First we'll discuss parallel axis theorem, then perpendicular axis theorem. What is parallel axis theorem? Since now it's easy to understand because you know about center of mass by now. So parallel axis theorem, what it says, suppose I make a random body. It's a random body. Now visualize it. Visualize this body as it is present on my hand. Yes, my hand is like this, na? This is my hand. You're able to see. The axis is like this. The axis on it will be perpendicular passing through it. Means the like this. Able to see my hand, na? Like this. My hand is the plane of the body, and this pen is the axis which is passing through its center. This is how I'm trying to show it here. Axis I have not drawn yet, but I'm drawing it now. This is the axis, and it is passing through the center of gravity. See, what is center of gravity? Center of gravity is actually center of mass. Both are same. Now, if you know, because there are several results for finding out the moment of inertia of a body about center of gravity, you will learn them how to find for a uniform body the moment of inertia about center of gravity using the integration part also. But for now, just remember you will be having the results of a moment of inertia of a body about the center of gravity. Now, suppose in a question they have asked you find out the moment of inertia of the body about some axis which is parallel to the axis passing through the center of gravity, this axis, and dd dash. Iy dash is given to us you have to find out moment of inertia of the body about IDD dash. It's given the mass of the body is capital M. Okay. Now, according to this parallel axis theorem, IDD dash is given by IYY dash, the moment of inertia of the body about center of gravity, plus its mass into the distance between the two parallel axes. Theorem, two parallel axes. In this case, suppose x, then m into x square. This is what the parallel axis theorem is. Now just tell me, did you understand this? Now see, what natural doubts you should get now. Natural doubts are, sir, you said the moment of parallel axis theorem IDD dash is parallel to the YY dash axis. And in your diagram, just you have explained us, the body was on your palm and the axis was perpendicular to it, passing through it. But now, suppose Shyama says something else. Shyama says that I won't have the axis perpendicular to the body. I want to have the axis passing through the center of gravity of the body along the along your hand, along the palm, like this. Will parallel axis theorem still holds? The parallel axis theorem will hold in every case, whatever may be the angle of this axis, but it should be passing through the center of mass of the body, and the IDD dash that you will be calculating, in this case when Shyama has said the axis is along the plane passing through the center of gravity, the other axis about which they have asked, that should be parallel to this given axis. Miss, my finger you're seeing, the axis about which the moment of inertia they are asking now should be parallel to the axis passing through the center of gravity. The important thing is the orientation of the axis passing through the center of gravity can be anything, but the moment of inertia in question about an axis, the moment of inertia about an axis in question should be parallel to our center of gravity axis. Understood? Then only this parallel axis theorem works. Is it okay?
Yes, sir.
Everyone, Shama, okay?
Yes, sir.
Okay, Radhika? राधिका तो माइक काम नहीं कर रहा लगता है. राधिका मैसेज कर दिया करो अगर समझ में आया तो, या कोई डाउट हो तो मैसेज कर देना, मैं देख समझ जाऊंगा. मैसेज आ गया. Yes sir, good. Now this is one axis, one parallel axis theorem. See, in this I'll tell you one thing, the point where students do most of the mistakes. See, I'll give you a situation and then ask you the moment of inertia. I'm giving you a situation. Suppose I'm framing a question. This is my disk. Okay. Now, in the given question, they have given the moment of inertia of the body about this axis, y dash, is mr square by 5. Now, what is the moment of inertia of the body? Wait. Question is yet to be completed. About an axis which is at a distance of 2d from it, distance of d by 2 from it, given the radius of this disk is d. Moment of inertia is md square by 5. And one more thing, this y dash is at a distance of d by 4 from one end. Understood the question now? The question is, the radius of, there is a disk, the radius of the disk is d. Now the moment of inertia about an axis I y dash is given to us md square by 5. This axis is at a distance of d by 4 from one end. Now we want the moment of inertia about I x x dash. Using the parallel axis theorem, try to calculate it. This is just frame domain.
So 1 minute, can you move up?
So one more thing I forgot to tell. This x-axis, this one, na, this is at a distance of d by 2 from it, from the center. This axis xx dash is at a distance of d by 2 from the center. Array, how can it be? Sorry, not d by 2. It cannot be d by 2. It's d by 3. D by 3 from the center. Actually, it was not needed at all. You could have calculated. No, not needed. You could calculate it. Are you able to do it or you want me to do it? Haripriya? Shama?
I'm doing.
Okay.
So you said that x dash is a distance of d by 3 from the center.
DYC? No. No, 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 no. Earlier I said, but it's not needed. You can calculate it. So much time. Let me explain you what I wanted actually. I think you got very much confused. See, how do we solve it? राधिका अपना माइक ठीक कर लेना, नहीं तो तुम्हारा तो पता ही नहीं चलेगा आंसर. See, what I was telling about how to solve, what I was focusing on. See, y dash is given to us, but the center of mass lies here. So we have to first find, using the parallel axis theorem, the moment of inertia about I g dash. This one, I about center of gravity. Now looking at it, very important. I Ig, I say, or y dash you can write as one Ig. Ig you have to find. So I dash, solution how we do it, I dash is equal to Ig plus, what is this distance? This will be d minus d by 4. This distance, d minus d by 4, it is 3d by 4, plus m into 3d by 4 whole square. But I dash is given to us. Md square by 5 is equal to Ig plus m into 3d by 4 whole square. Ig we have got, it is md square by 5 minus 9 md square by 16. You can calculate it easily now. Achha, it is given, it's coming negative. See, I have framed the question without knowing something. You can calculate, but moment of inertia will never come negative actually. It's coming negative.
From Ig to even Ix dash is also negative.
Just for the sake of understanding, keep it like this, because I have framed a question just to understand, make you understand. You have to calculate Ig first. Okay. Now 16 minus 45 md square by 16 into 5. Okay. This value you have got Ig. Now after you have got Ig, to get Ixx dash, again you will do this one. Ixx dash will be equal to Ig plus, what is the distance between center and this? Center to this xx dash. How will you find? It is d by 4 plus d by 2. 3d by 4. 2d minus 3d by 4, na? This distance you will get is 5d by 4. This distance is 5d by 4. Now to get this distance, you can get it using or there is another way of doing this one. This distance you will get by using d by 2 plus d by 4 minus d by 2 plus d by 4 minus d, because this radius is d. So it is 3d by 4 minus d. Again it's coming negative, na? Minus d by 4. It should not come negative. Actually, I have formed this question, na? That's why these things are happening. Don't worry about this negative and these signs. Just try to understand the concept. I have found out the Ig, then Ixx dash will be equal to Ig plus m into minus d by 4 whole square. That's all. Ig, you know, it is 16 minus 45 into md square by 16 into 5 plus m into minus d by 4 whole square. This is how you calculate ix dash. Understood? The focus, just focus on the concept, not on these number values. These number values I have just given to make you understand things. Why I did this one? Because this is the common mistake that students do. What they do now? What students do? In this case, iy dash is given, ixx dash is found. So they will just apply this formula. Ixx dash is equal to Iyy dash plus m into d by 2 whole square, and then they'll put the result. It's md square by 5 plus md square by 4. Final answer 9md square by 20. And this is wrong, totally wrong. This is a common mistake that students do, and I want you not to repeat it. Okay, what they have done, they did not focus
Got
upon the formula.
I got negative value.
Ah, don't worry about the negative value. The negative value you are getting, don't worry about the answer. Just try to understand the concept. The concept is this formula only applies for finding out the moment of inertia about an axis which is parallel to the axis passing to the center of gravity. So you, in every case, if the given axis is passing to the center of gravity, it's okay. Find using parallel axis theorem, the about moment of inertia about an axis is parallel to it. If it is not given, first find out the moment of inertia about the center of gravity. After you have found the moment of inertia about center of gravity, like I have done, find out the moment of inertia about the given axis using the parallel axis theorem again. This is the right method. This is correct method. That is common mistake. Understood? Okay. Now try to solve this question. Now these are the actual questions you should be solving. Solve it. Parallel axis theorem I have told. Perpendicular axis theorem I will tell later. What happened? What happened? No one is getting answer. It's easy question only. Haripriya?
Not able to find the axis of central.
Array, it's not needed here. That center of gravity, it's not parallel axis theorem. It's not, no need to apply here. I thought. Achha, what about you, Shyama?
Oh, so
Arrays. In this, see, in this Haripriya, it's not needed at all to use this parallel axis theorem. Four particles, each of mass 1 kg, are placed at four corners of a square. This is one corner. This is one corner. This is one corner, and this is another corner. Okay. Each of mass 1 kg is given. Okay, let me just make it big. Okay. Four corners, each mass is 1 kg. This is 1 kg. This is 1 kg. This is 1 kg, and this is again 1 kg. Moment of inertia of system about an axis perpendicular to its plane and passing through one of its center. Let's say you can take any center, but I am taking this one because they have shown the rotation also. Means this axis they want you to take. But remember, here the axis is coming perpendicular to the plane. Means the axis is coming towards you like this. Now see, there are, for this 1 kg, this 1 kg, which is just present here, there won't be any moment of inertia because the distance of this 1 kg from this axis is 0. And this 1 kg is at a distance of 2 meters. So its moment of inertia will be 1 into 2 square. Now for the bottom mass, if you see this bottom mass 1 kg, for this what will be the moment of inertia? 1 into, again it is a 2 meter distance now from this axis, 2 square. Now coming to this 1 kg, the third 1 kg, this one, it is at a distance, this one you have to calculate. It is at a distance of 2 square plus 2 square, 2 root 2. So its moment of inertia will be 1 into 2 root 2 whole square. The total moment of inertia about this axis is 4 plus 4 plus 8, 16. Answer. You need not have to apply moment of this parallel axis theorem here because they were point masses, na? No need at all. Understood?
Yes, sir.
It was easy, not needed at all. Parallel axis theorem. Everyone, Shama, okay ना? राधिका समझ में आया? मैंने एक्सपेक्ट किया था राधिका would be solving it. I thought everyone could solve it because it was the easiest one, but don't know why. Almost हो गया था. But you took so much time. अच्छा, try solving this one. Just try to understand this. Oh, sorry. Not now. This needed some more things. This needed knowledge of perpendicular axis theorem. You won't be able to solve. Acha, let me give you one question. The important result needed for this, I'll give you. Let me give you this question now. Hmm. See this question. Two identical spheres, each of mass 2 kg and radius are fixed at the end of light rod, so the separation between the centers is this. Moment of inertia of the system of an axis perpendicular to the rod passing through its middle point. The one information that you need here is the moment of inertia of a sphere. This is an array. Let me draw it. The information that is needed to you is moment of inertia of a sphere about an axis passing through its center of mass or the center of gravity. Here, this one is 2 by 5 m into r square. Means this Ig, value of Ig is equal to this. Okay, where m is its mass and r is its radius. Only this important information is needed for you. Later you will remember it. Only this thing is needed. Let me delete that question for perpendicular. Do you want me to draw the diagram for this or it's okay? They want the moment of inertia of this system about an axis passing through the center, this one, about this pink rod. Its diagram. After this, I'll teach you perpendicular axis in the next class. I think it will take time for you to solve. So take it as a homework. Okay, take it as a homework. Try to solve at home. Then give me the answer because only 1 minute. 1 minute is left. Let's see if you can solve it in 1 minute. Okay, take it as a homework. Okay, take it as homework. In the next class, we'll do perpendicular axis theorem and then solve some more questions. And then we will move on to the moment of inertia of the uniform bodies. Uniform distributed mass. Like we calculate center of mass for uniform distributed bodies, na? Uniform mass distribution. Like that we'll do. Moment of inertia calculation. Let's end it then. Bye bye. Night.
That's it.